Hello everybody. In this video, I'm going to be dealing with the normal to a curve. Now, what exactly is a normal to a curve? So, it all branches off of a tangent to a curve. If you remember, when we find the derivative of some function, we are essentially finding the tangent line to some function, right? So, and usually it's represented as the gradient, right? So the gradient is the first derivative of some function. So if we look at some function, let's say, I don't know, I'm just going to give some cubic looking function, not the most perfect function, but it's fine. And let's look at some point. Let's look at this point, okay? And let's take the tangent line. The tangent line will look something like this. So it'll look like this. Voila. So we call this the tangent line. So this is the tangent line. Once we take the first derivative at some point over here, we're finding the gradient at that point, right? And that's a tangent. It only intersects at one point, okay? However, what is the normal? The normal line is going to just be perpendicular to the tangent line. So the normal line would look something like this. So let's just draw some line like this. That looks good enough. And this would be the normal line. Okay, and this specifically has to be perpendicular. Okay, so it must be perpendicular to the tangent line, meaning that the equation of the normal line has to be, so we would just call it the gradient. Remember, it's still a gradient, but it's a perpendicular gradient. So we will represent it as m norm is equal to -1 over capital M, or sorry, m, which is the gradient, but the tangent. Okay. So this is the formula for the norm. As soon as we know what the tangent is going to be, meaning the gradient, all we are going to do to find the norm is just say -1 over m tangent. Let's just do like maybe one example to see how this is used. Otherwise, this is not very hectic and heavy on in terms of content. Okay, so here's our question. It says here, determine the equation of the normal line to f of x equals x squared plus 4x plus 3 at the point where x is equal to 2. Now, first things first. Remember, I said that the normal line is perpendicular to the tangent line, where the equation of the gradient for, the equation for the normal line is essentially just going to be -1 over the tangent, right? And this is all in terms of gradients, by the way. So meaning we need to first find the tangent of the function, right? At the point x equals 2, and then we need to use the formula and then multiply it by -12. That's a -12. No, I need to multiply it by -1 over the tangent thing to find the normal line, right? Okay, let's get into the example already, and then we'll see how this is going. Okay, so first things first, we need to know that the tangent, right, the equation would be in the form of y equals 2 f prime of, it will be 2, right? Because remember, we're doing it at the point 2. X times x plus c, right? So we need to get it in this form, where this is basically the gradient at the point where x is equal to 2, okay? So obviously, we need to find f prime of 2. So we need to find f prime of x. Now, f prime of x is just going to be the derivative of the original function, and we need to do the derivative of each one. So the derivative of x squared is just 2x, and the derivative of 4x is just 4, and the derivative of 3 is just 0. So meaning we have f prime of x. Now we need f prime of 2, which is just going to be, wherever we see x, we replace it with 2. So it's 2 times 2 plus 4, which should give us 8. Okay. So meaning our equation right now is going to be y is equal to 8x plus c. And in order to find our intercept, we obviously need to substitute our points in. But the question is, are we trying to find the equation of the tangent or the normal? So notice that the normal is perpendicular to the tangent, meaning it'll have a different y-intercept. So there's literally no point of finding the y-intercept for the tangent. The only reason why we're using the tangent is so that we can substitute it into the normal formula. Okay? So notice from here, right, now that we know all of this, the gradient norm is equal to negative 1 over gradient tangent, right? Meaning that we have negative 1 divided by 8. And that is our gradient for the normal line, okay? So negative 1 over 8. So therefore, this implies to us that for the norm, so far what we have is y is equal to negative 1 over 8 x plus c. Okay, and now all we need to do is just solve for c. And do we have the points on the graph? Yes, we have x equals 2. We just need to find y. Okay, so in order to find the y value, we need to determine f of 2. Okay, the output for that coordinate. So f of 2 is just going to be wherever we see x, we replace it with 2. So it's going to be 2 squared plus 4 times 2 plus the constant, which is 3. Okay. And then this is just going to be 4 plus 8, which is going to be 12. 12 plus 3 is equal to 15. So which means that the intercept is going to be 15, which is f of 2. So this implies to us that the coordinate is going to be 2 and 15, okay, at the point. Also, why did I say intercept is at 15? that is not what it is. So yeah, there we go. Now we can substitute it in. Okay, so notice we have y equals 15. And then it's going to be negative 1 over 8 into x equals 2. Okay, and then we have plus c, and then we just solve for c. So we take everything else over, so it's going to be 15 plus 2 over 8, which is just 1 over 4, is equal to c. So therefore, c is just going to be equal to 15. When we want to rewrite it, just put it in a calculator. So what we're going to notice here is we're going to get 61 divided by 4. So therefore, the equation of the normal line to f at x equals 2 is y equals to negative 1 over 8x, and this will be plus 61 over 4. And there we go. That is how you find the equation of the normal line, and also how you deal with normals to a curve.